Hello everyone. This is the continuation of the tutorial that I sent earlier. This is question 10. So question 10 reads, if 25 kg is the maximum mass M that a person can hold in a hand when the arm is positioned with a 105 degrees angle at the elbow as shown. So we had the hand. Okay, you've seen it in the tutorial, but the diagram that I can draw is we have the arm. Okay, I'll draw it like this. Okay, and then this is the elbow. Then from the elbow we have the biceps here. So the bicep is at 105 degrees and it is 5 centimeters from the elbow. Then we assume that this hand has got a mass of 2 kg. Okay, says that assume the forearm and hand have a total mass of 2 kg. So we'll have the force, the center of gravity, which is at 2 kg here, of course, multiplied by 9.8 so that we get the weight. And then the maximum force that this hand can hold is 25, the maximum mass it can hold is 25 kg. And then to get the weight of that, we multiplied by 9.8. Okay, this is what we have. Okay, so I'll read the question. If 25 kg is the maximum mass M that a person can hold in a hand when the arm is positioned with a 105 degrees angle at the elbow as shown, so something like this, what is the maximum force that the bicep muscle exerts on the forearm? Assume the forearm and hand have a total mass of 2 kg with a center of gravity that is 15 centimeters. So there's something we've left out here. The distance from the elbow to the center of mass is 15 centimeters. Okay. And then what else? From the elbow, and that the bicep muscle attaches 5 centimeters from the elbow. So we have this. Now we've also, according to the diagram we also have that the distance from the elbow to the end of the arm there is 35 centimeters. Okay, that's the information we've been given. Now with this information, how do we find the force that is in the bicep? Okay, the bicep is the muscle that is on top of the bone. Yes, we've got the bicep and the tricep underneath. So we're talking about the bicep, which is the muscle there. So we want to find out how much force the bicep will have for it to be able to hold a force of 25, a body of 25 kg. Okay, so now for us to be able to do that, we need to just use the condition of equilibrium, which is that the net torque is equal to 0. Right? Now for the net torque to be equal to 0, meaning that the system is in equilibrium. How do we go about that? We are going to have to find the torque about the bicep, the torque about the center of gravity, the torque about the mass M. Okay? So we will have, I'll take taking torque about the elbow. Okay, taking the torque about the elbow. Now, if we take torque about the elbow, meaning we are starting from this position here, all right? So we will have this torque, which will be the anti-clockwise torque. We'll have this torque, which will be the clockwise torque and the clockwise torque. And just like I did with the previous question, on question 8, I'm not going to use the negatives and the positive. I'll just split the two by the equation sign so that we'll have only positive values. So I'll start with the counterclockwise torque. Okay, now the counterclockwise torque, we have the direction, which is 5 centimeters, and in meters that will be 0.05. The perpendicular force is not exactly this. The perpendicular force is actually the force acting here. Okay? Now that force is acting at an angle of 105. That's the force that we are concerned with. And that is going to be the sign of the force F. So FB, B standing for bicep. F bicep sine 105. Okay, that's the force. And then the perpendicular distance is 0.05 meters. Is going to be equal to if we look at the distance here, the perpendicular distance is 15 centimeters, which is 0.15, okay, 0.15 meters multiplied by 2 kg multiplied by 9.8, so that we have a force. That will be added to the distance here from the elbow to the end of the arm is 35 centimeters. Converting it to meters, we'll have 0.35 multiplied by 25 kg, which is the 25 kg here. 25 multiplied by 9.8. Okay, that's what we have. Now, if we simplify this, we'll have 0.048. F is equal to 2.94 plus 85.75. Okay, now once this is simplified, we divide by 0.048 divided by 0.048. We'll find that F is going to be equal to 1836.4 newtons. Okay, this is the force that the biceps are going to have to exert to be able to lift a force of a mass M of 25 kg. Okay, this is a very big value. If my calculations have got no errors, that's what I have. All right, so this is the answer. This is how we go about solving question 10. So meaning that we have concluded tutorial sheet number 8. Yeah. Tomorrow we are going to meet for a Zoom meeting at 14 hours. I've already sent the schedule to Kondwani. So once we go through that, as in try to see. I'm sure you've already been watching the videos, but you've had some challenges here and there. So I want us to come and talk about those challenges tomorrow. We can have an interaction and if possible schedule another one so that we tackle tutorial sheet 7 and 8 completely before we move on to tutorial sheet 9. Okay, so that's all from me and see you tomorrow.